So I'd like to talk to you about my preferred method to simplify complex fractions. Complex fractions are fractions that look like this one here, given in the example, where you have some big fraction, and within that fraction are a nested layer of smaller fractions. And there are a couple of different ways to simplify something like this. And this video, the purpose is to show you the method which is slightly faster than the alternative way. That method is more reliable, I would say, easier to remember than this one, but this one is much faster. And so I would recommend to use this method if you are going on to pre-calculus in particular, because you'll have to do a lot of these kinds of problems. So here's the basic idea. You know, we have two layers of fractions here. I will call them big fractions and small fractions. And the idea is to, first of all, find the least common denominator of the small fractions. And then the idea is to multiply the numerator of each small quantity by this LCD. So what do I mean? In this problem, I see two small fractions here. One of them is 4 over x, and one of them is 4 over x squared. Now pretend that you were adding these fractions together. If you were adding these fractions together, what denominator would you try and make both of them have? Well, to get both of these to have the same denominator, you can only go up from what you have. So x has to go up and be increased to x squared, because x squared cannot be decreased to x. So in our case, the LCD would be x squared. So I'm going to then go into this problem and multiply every single numerator, every single small quantity at the numerator level by a copy of this LCD, x squared. And then I'm going to go in and I'm going to simplify as much as possible. So take a moment. If you are going to simplify each of these individual 4 products here, top left, top right, bottom left, bottom right, then how would you go about doing that? Let's try it together down below. So 2 times x squared, not much you can do with that. 2 times x squared is 2 times x squared. And likewise on the bottom left, x squared times 1 is x squared times 1. Now times 1 doesn't change a quantity, so let's leave that as x squared. And so when you deal with the fractions, that things start to get interesting. Take, for example, here on the bottom right. On the bottom right, we have a factor of x squared in the numerator and a factor of x squared in the denominator. And these two common factors cancel each other out, leaving only the subtracted 4 behind. Now I think the top right may be the trickiest of all. Let's look what's going on there. Here in the denominator, I have a single x. Here in the numerator, I have 2 factors of x. One of those x's can cancel the other x in the numerator, but that leaves a single x behind that has not been canceled in the numerator level. One of those x's cancels, but one of those x's remains. So by doing that step, I've gotten rid of this nested behavior where I had fractions within fractions. And I'm back now to having a problem like I had in section 8.1, where I can simplify this by factoring and canceling common factors. So take a moment and try it on your own. Okay, let's do it together. So, numerator. This numerator these two terms in the numerator have a commonality. They both have a 2, and they both have at least one x. So factor out that 2 and that x, and what's left behind? The 2 and a single x comes out of the first term. A single x is left behind. The 2 and a single x comes out of the back term. A 2 is left behind. And you can always check this. If you don't quite believe, you can multiply this back through. 2xx would be 2x squared. 2x2 would be 4x indeed. And here in the denominator, I would have the difference of squares, x plus 2, x minus 2. So the common factor of x plus 2 will cancel out. I'm left with 2x over x minus 2.